Dear all, thank you for the chance to introduce our recent work, Shared Aperture for G LTE and 5G millimeter wave antenna in mobile phones with enhanced millimeter wave radiation in the display direction. For the millimeter wave arrays for mobile phones, the beams 1 to 5 have been widely studied. But due to display obstruction, realizing beam 6 in display direction is challenging. Moreover, coexistence of 5G and 4G mobile communication requires co-design of millimeter wave arrays and 4G antennas. Based on these, we proposed a shared aperture 4G and 5G millimeter wave antenna design. The main work consists of 3 parts, namely, 4G antenna design, 5G millimeter wave array design and shared aperture design. Firstly, the overall structure is given here. The proposed antenna consists of 7 PCBs, sub 1 is used to print the structure of the 4G, 5G antenna, and the main ground. Sub 2, sub 4 are used as metal bezel. Subs 5 and 6 are used to print the floating patches. The overall size is suitable for 6.5-inch mobile phones. Here is the single 4G antenna design. The values of capacitors and inductors are fine-tuned for better impedance matching, for resonances can be achieved. The desired low band and middle high band are covered. The current distributions of resonance modes are shown at right. Single 5G millimeter wave array design is shown here. For the array 1, the radiation is in both display and back cover directions. For the array 2, the radiation is mainly in display direction, and back cover direction is reduced. For the array 3, the radiation is mainly in display direction, but back cover direction is enhanced. For the array 4, as can be seen, the clearance affects the millimeter wave array slightly. IDC is used to replace the solid ground for shared aperture design, which is high pass at the millimeter wave frequency band and low stop at the 4G band. In the shared aperture design, the effect of the 5G millimeter wave array on the 4G antenna are slight. The resonant frequency of the millimeter wave array is shifted to the higher frequency band with the solid ground replaced by the IDC structure. Finally, the beam steering patterns of 5G millimeter wave array are shown here. The proposed array has a fan-shaped beam in the display direction, and the 3dB beam steering range reaches 90 degrees. The beams can steer from 60 degrees to 120 degrees with the low side lobe level. The side lobe levels for 45 degrees and 135 degrees beam directions are high due to only 4-element and large element spacing. A prototype is fabricated and tested, and the measured and simulated results are in good agreement. The attractive performance of shared aperture design, a small clearance and enhanced display direction radiation makes this design could be a promising candidate as a millimeter wave array for the modern mobile phones. Thank you for your watching.